Are we capable of identifying similar figures?
Yes.
Excellent. A similar figure would be a figure that is the same shape but could be a different size. Are the angles in a similar figure the same? Yes. So they're congruent, right?
Yes.
And then just to clarify, corresponding angles or sides would be angles or sides that are in the exact same spot on similar figures, right?
Yes.
So if you are looking at AC, side AC of this triangle, what is the corresponding side of the other triangle? Yeah. And we know that these two are similar because it says so right there. ABC is congruent to DEF. And then these guys are called what again? So because I have two congruent markers right there on angle D, what angle is congruent on the triangle ABC? Okay. Yes, no? Sliding on down to number 2, proving or disproving similarity. We had rectangle A, B, and C. And you guys, looks like here, because they were all rectangles, we didn't have to worry about the angles, because in a rectangle, all angles are what?
93.
Eyes are up here, yes, no?
Yes.
I'm going to ask that question again. In a rectangle, all angles are what?
93.
So we know all of the angles are congruent, no matter what. So we just needed to figure out if comparing A and B, we compared A and B, right? Is this side and this side and this side and this side would put together proportionate, right?
Yes.
So we did 10 over 4 for rectangle A, and we did 5 because 5 corresponds to 10, so we did 5 over 2 because 2 corresponds with 4. And when we multiplied, we realized that 2 times 2 is 4, 5 times 2 is 10, therefore they're proportionate, which makes the rectangles similar, right? And then I'm not going to go through AC and BC, but we did basically the exact same thing, and we realized that going from 10 to 12 and from 4 to 5, we were not multiplying by the same thing. And then the girls, Carly and Maren, said, hey, instead of doing proportions, actually they did do a proportion, but instead of solving using bubbles or arrows, they just found a common denominator. Is that legit as well?
Yeah.
And they realized 25 over 10 is not the same as 24 over 10. Excellent. The rule is this then. Everyone on the count of 3, read. Number 5. We're going to read the rule together, and 1, 2, 3.
For 2 polygons to be similar, all corresponding angles must be congruent, and all corresponding sides must be similar.
Stop. All corresponding sides must be similar, not equal, right?
Yes.
And how do we know if they are similar? What do we do?
In other words, they must be in proportion.
They must be proportionate, right? Excellent. You guys read very well together. Number 6 is just another example of using proportion to prove or disprove similarity. In this case, we proved it.